So next, organic reaction mechanism. Organic reaction mechanism. So generally, organic reactions takes place by the reaction between reactant with substrate, with the reagent. So in organic reactions, reactant is also called as substrate. Reactant that is generally termed as substrate. Substrate reacts with the attacking agent, which is called reagent. Then we will get intermediate first. First we get intermediate. From intermediate, finally we get product. So that is the general reaction mechanism, organic reaction mechanism. Okay. So first, substrate interact with the attacking agent, which is called reagent. Okay. Substrate. Here substrate is reactant, but we generally call as substrate. Substrate reacts with reagent, which is also called as attacking agent, reagent. Here first we get intermediate substance. From intermediate substance, finally we get products. Intermediate substance gives products. Okay. So this is the general reaction mechanism which is involved in all organic reactions. Okay. And a substrate which is reactant. Okay. So it gives carbon to the new bond formation. Okay. To form the product. Then, so formation of new bond that takes place due to the cleavage of older bonds present in substrate. Okay. So this cleavage is also called as fission. Okay. So generally fission takes place in the substrate. Due to fission we will get final products. Okay. So fission, that is in two types. Homolytic fission, heterolytic fission. Okay. Substrate converts into products through the formation of intermediate. First fission, cleavage of bonds takes place in the substrate. Okay. And we'll get products finally with the new bond formation. So older bond cleavage is called fission. So fission is in two types. Homolytic fission and heterolytic fission. Okay. Next to fission of covalent bond. So fission of covalent bond. Fission, this is in two types. Okay. First one is homolytic fission. Okay. So two types. First type, homolytic fission. Homolytic fission. Okay. So coming to homolytic fission. For example, AB substrate is there. Okay. So a covalent bond is present in between these two atoms in the AB molecule. Okay. So in homolytic bond fission, each atom separates with one electron. Okay. So due to the fission between A and B. So a single, for example, a single bond is present in between A and B, single covalent bond. So a single covalent bond is equal to a pair of electrons. Okay. So during homolytic fission, each atom separates with a single electron. A pair of electron equally shared by two atoms here. Okay, equally accepted by two atoms. A accepts one electron and B accepts one electron. And those two atoms, they are separated with a single electron. Okay. Then we'll get A and B. Okay. Here dot indicates single electron. This is also called as free radical. So we will get free radical during homolytic fission. Okay. So in homolytic bond fission, each atom separates with a single electron. Okay. So in homolytic fission, in this type, each atom separates with a single electron and converts into free radical. Converts into free radical. So this is homolytic fission reaction. Okay. And free radicals, these are highly reactive in nature. Okay. So single electron, unpaired electron is present here. So free radicals are generally highly reactive in nature. Okay. Next, heterolytic fission. So in heterolytic fission, for example, A, B molecule is there. Okay. Here, B atom is more electronegative than A atom. Okay. And during fission of covalent bond, B, it gains total electron pair. It attracts total electron pair. Okay. So it separates out as a anion with more electrons. And meanwhile, A, which is less electronegative than B, it separates out as cation. Okay. So B that gains total pair of electron and it separates out as anion. So minus charge indicates more number of electrons and a plus charge less number. Okay. So during heterolytic fission, we'll get a pair of ions. Okay. So a pair of ions are formed during heterolytic fission. Okay. So in this type, one atom gains electron pair and separates as anion, and another atom separates as cation. Okay. So we'll get a pair of ions here. Okay. Next.